before 10 Mountain Time. Well, you may remember just before Christmas, astronauts in the International Space Station realized they needed a wrench, but they didn't have one. And what were they going to do? Well, the 3D printer came to the rescue. They used a 3D printer to make their missing wrench after the plans were emailed to them from back on Earth. And of course, they had a 3D printer and they had the material they needed, the plans, and voila, they had a wrench they could use. 3D printing may seem rather, magical, and perhaps not really applicable to our daily lives. I mean, people are making toys and that kind of thing. But my guest today, Dr. Paul Tinari, believes that very soon 3D printing will be playing a much bigger role in all of our lives. Dr. Tinari is a professional futurist, an engineer, a writer, an educator, and the author of The Joom Destiny, How 3D Printing Will Revolutionize Your World. He founded the Pacific Institute for Advanced Study. He's consulted with NASA. He's talked to the U.S. Navy about using 3D printing, and it has saved them a ton of money. Dr. Tinari joined me in studio to talk about 3D printing and the future and whether or not we, businesses, governments, are prepared for it. And I started off by asking him to explain really what the state of 3D printing is right now.
Okay, well, believe it or not, the concept of 3D printing, the theoretical concept, was invented in 1637.
I don't believe that.
There was a mathematician who postulated that every object could be broken down into an infinite series of parallel planes. And that's exactly what 3D printing does. It takes an object, and the computer has a design of the object in its memory, and the software cuts it into innumerable little horizontal slices.
Little cross-sections.
Cross-sections, right? And then the printer then reproduces each of those slices using the minimal amount of material. So the amount of waste is virtually nil compared to traditional manufacturing. And you can actually manufacture things that couldn't be made any other way, incredibly complex structures that would cost a fortune to make any other way. So
like what?
Well, very, very detailed design things that have undercuts and so on are very difficult to make by traditional manufacturing, and so, but 3D printing can do them easily. So the actual modern 3D printing started about in 1987 with a gentleman who invented laser sintering. So he had an idea for having a bed of material which a laser would then melt into a particular shape, and then you add more material on top and melt it again, and then you build up the object layer by layer. And of course, these early 3D printers were inefficient and not that accurate and incredibly expensive. But with time, they became better and better and better, just like any other technology. And in the early 2000s, I was invited to address the Naval War College. And the big problem faced by the Navy, which they were asking me to address, was their spare parts problem. That a naval task force, when it goes to sea, has to bring 20 to 40 million spare parts. The lack of a single spare part could threaten the mission. And the solution I came up with was for the Navy to develop their own proprietary 3D printers that could manufacture parts as needed.
And do they do that?
Well, that's exactly what happened, is they put in multi-billion-dollar effort, and they have now produced their own 3D printers that will manufacture anything in titanium, in stainless steel, in plastic, or anything you want at sea they can manufacture as needed. And I came up with this term, Joom, which means just on order making. In other words, you just make something when it's needed, never before. So this is a great advantage because you no longer have inventory. So look at the inefficiencies of traditional manufacturing, is that a company has to sit around with its marketing department and say, well, how many red cars do we need? How many blue cars? How many 4-cylinders? How many 6-cylinders? How many cup holders should we put in? These are all questions that the marketing department tries to answer. If there's no interest in the number of red cars they produced, or if just styles change and more people want 6-cylinder than 8-cylinder, then these cars just sit there in inventory. And what is the cause of a recession? A recession is when inventory is sitting unsold, and that the result is a recession. Well, 3D printing eliminates that because you only manufacture an item when there's a paid order for it. So in the future, you go to a website and you will have a list where you design your own car. What color do you want on the outside? What color on the inside? What's the number of cylinders? Do you want diesel? Do you want gasoline? Do you want electric? Do you want 7 cup holders? You design the whole thing. And then when you press enter, you then go to the finance page and then organize the financing, the monthly payments and whatever. Do you want to lease, or do you want to lease to own, or whatever? Then you press enter, and then that car design gets sent to the assembly sphere, not an assembly line, an assembly sphere that'll fit in the traditional garage, very small, and then that car gets manufactured then and there according to your exact specifications, and then within 2 business days gets delivered to your door.
Are people building cars? I mean, maybe not like to order like that, but are people building cars right now using that 3D printing?
Local Motors, which is a custom design car manufacturer, is now building fully 3D printed cars, and there's a group in Winnipeg that built from scratch their own 3D printed car, and amazingly enough, this car had better performance than anything produced by the large companies. It had better gas mileage, lower aerodynamic resistance, better performance, and so on, and so they did a much better job. And this led me to the conclusion that you're going to have major disruptions occurring when you have small local manufacturers. Like in a place like Port Moody, you could have a car manufacturer, right, located in a small, tiny little warehouse, producing cars better than could be produced in Oshawa.
And only employing 4 people.
Employing no one. You just have one administrator
to push a button,
and maybe one maintenance person to push a button and maintain the thing. And these cars could be sold for $5,000. And this is why I'm giving a heads up by writing this book, because people should not be blindsided by what's about to happen.
It sounds like it's a fundamental, it's a mega shift.
Yes, it's a mega shift as significant as the invention of the steam engine. And yet most people are only dimly aware of it. Right? When I talk to most people, they've heard of 3D printing, but it's only for making toys.
Right, yes.
Right. And sure, you can make toys with it, but I should also say that that's disrupting a major industry as well, because if people start manufacturing their own custom-designed toys within the home, now that affects international trade, because you no longer need the container ships that are shipping goods to Vancouver. There's a major industry right there. So it disrupts the international trade, it disrupts foreign economies. The development that's occurred in countries like Germany, Japan, South Korea, China has occurred through low-cost exporting of goods to North America. Right?
Manufactured goods.
Right. Now, if you eliminate that means to development, you've eliminated a major chance that countries like Bangladesh and so on have to develop. So this has major political ramifications all over the world.
I think this has come to a lot of people's awareness, or a small part of it has come to people's awareness most recently because of the fact that one of the astronauts in space was sent an email that included the plan for a wrench, which he was then able to print in the spaceship and use on demand, as it were.
So essentially they have created the Star Trek replicator, where you're now shipping the information to the ISS, the International Space Station, and now the information is used to manufacture the item. It costs about $10,000 per kilogram to ship items up to the International Space Station. Now you just have to ship the raw material, and the raw material can be made to make anything they need up there as they need it. So it's an incredible breakthrough. And we're going to be seeing 3D printers playing a major role in all future space exploration and development. The Mars mission will definitely be using 3D printers to supply spare parts and items that they need for the 9-month mission to Mars.
When you mentioned Star Trek there, and of course, the science fiction and the fantasy of the future, but in so many ways, we're there in so many ways. And also, I'm wondering how quickly things are changing. Do you find it just going at a breakneck pace now?
You can see mirror images of what's happened, for example, with laser printers. 20 years ago, no one had a laser printer in their home, right? They were incredibly expensive, $2,000, $3,000, $4,000. So if you wanted a high-quality report printed, you went to Kinko's and you got them to do a high-quality laser print. Now, everyone has a laser printer in their home. They're so cheap, they're almost disposable. They're almost
the ink's more expensive than the printer.
The cartridges are more expensive than the printer, right? The same pattern is going to happen with 3D printers. They were incredibly expensive, but the price is falling in half every year. So you can now get a 3D printer for $400. Not a very good one, but every year the quality improves and the cost falls, right? So in the spring, we're going to see a whole bunch of brand new machines being released by various groups from around the world that have overcome the problems intrinsic to the early 3D printers. For under $1,000, you'll be able to print out anything. So metal parts, new bicycles, new washing machines, anything you want. Now, I've identified spare parts as a critical issue around the world. When I was in the third world wandering around, you'd see these abandoned outboard motors or abandoned lawnmower, whatever. Why were they sitting there? Because there was no spare parts for them. The company that had manufactured had gone bankrupt. So one of the things I'm working on right now is to make a warehouse, an online warehouse of millions and millions of spare parts that people can download and print out with their new metal 3D printers. So if you're missing a piece to your coffee machine and the company no longer supports that model, which happens quite often.
All the time.
Right? You go to my website, you enter the model number, and you say which part you're missing, and you now print it out. You've got your coffee machine working again. And that'll apply to anything. So you're wearing glasses right now.
Yes.
Right? If you sit on your glasses and break the lens, what would it cost you to replace that lens?
Oh, man, hundreds of dollars, right. I'm thinking, yeah.
$600-700, right? In the future, you'll enter your prescription and the model number of your frame and so on, and you'll now download a design for the lens and print it out in polycarbonate and then put it into the frame, and there you go. For 99 cents, you've replaced your glass. So let's say you're not happy with a specific part of your body. You can now redesign it yourself and have it printed out using your own stem cells. So this means that there are people alive today who will not have to die. Because why do people die? Because they have an organ failure, right? But if your liver is failing, you can reprint a brand new liver and then have it implanted by a surgeon to replace the damaged liver.
And can that happen now?
It's being done on animals. They've done experiments where they printed out new bladders and new kidneys for dogs, implanted it, and the dog survived and is prospering. And now it's not an insignificant thing. If you get bladder cancer, you have your bladder removed, you have to spend the rest of your life with a bag. But if you could print out a new bladder and have it implanted, this is your bladder. It's not someone else's that's being implanted. It's your cells.
So you're not dealing with rejection.
Right.
Yeah.
You don't have to take rejection cells. It's your bladder, and it now function like your brand new bladder. This can be done for every organ in the body. So obviously, women who've had breast cancer, have had a breast removed, can now reconstruct. Now, this is not an artificial breast. It's the actual replacement for their missing breast that contains milk glands and ducts and nerves and blood vessels, everything, just like the original breast. Incredible breakthrough.
This, of course, has implications as well. If we're not dying from these things that might take us out in our 60s, 70s, 80s, we're going along to, who knows where, there's going to be a lot more people trying to live on this earth.
Yeah, there's a number of scientists who speculated the ultimate human life expectancy is between 120 and 150 years. If you can have your organs replaced at the same rate as they're failing, for example, if you've been a smoker when you were younger but you've now quit, well, you can have your old lungs replaced with brand new lungs, and essentially you're good as new. It's as if you never smoked, right? And so there's no reason you should ever die, because anything that happens, kidney problem or heart problem or even a brain problem, let's say you're starting to suffer from Alzheimer's, well, you can print out new brain cells as well to replace the ones that are damaged by Alzheimer's disease.
That has implications, of course, for resources, but then on the other hand, you point out that food can be produced in a whole new way too, especially animal protein.
Think of the inefficiencies of producing meat, is that you have these huge animals that produce incredible amounts of methane and waste, and they have to be fed and housed and taken care of, right, and then slaughtered. It's a very complex and messy process. Compare that to taking stem cells from the cattle or the pig or the sheep, using those stem cells to make the select cut of meat you want. And so you have a perfect filet mignon, a perfect rump roast, a perfect lamb filet. It tastes and looks and is exactly the same as the original. The nutrition is the same. It looks the same, tastes the same, but it's made by a 3D printer in your kitchen, right? A nice compact place. You don't need the farm anymore. So imagine the effects this is going to have on Canadian agriculture for once, right? I mean, if you can produce your own milk, your own meat, your own agricultural products, you don't need the farms anymore, and you don't need the politicians to regulate it either.
When you talk about these things, they sound mind-boggling. It sounds like this can't really be that close. How close are we, do you think, to these kinds of major changes?
Well, as I've said, the military, which has almost unlimited money in the States, is already doing this. So, and it's only a matter of time before this technology trickles down into the civilian sector and becomes affordable for us.
Oh, my heavens, yes, what a time. Well, this has been fascinating. You just have this little peek into what you're looking at pretty much every day, yeah. That's Dr. Paul Tinari, a futurist, engineer, writer, educator, and author of The Joom Destiny, How 3D Printing Will Revolutionize Your World. Mind-boggling indeed. And in the book, Paul Tinari pulls together a lot of what's happening right now with 3D printing, where the near future is, and poses some questions about how prepared are we when it comes to business, government, legislation, regulation, employment. So many things fall out from the changes that could come with this 3D printing revolution. This is North by Northwest on CBC Radio 1. It's 6 minutes before 9. Here's the new pornographers.